We will use round robin with quantum of 2, and then in Q2 we're gonna use a non-preemptive scheduling algorithm, which is first come first serve. What else is characteristic to this algorithm? Processes arrived in the highest priority queue when they're about to start their CPU burst. So we can see that in Q0, here I put the arrival times and the processes arriving at different times, so 1 at 0, 2 at 2, 5 at 8, and so on. So each process, when it's about to start the CPU burst, will go into the highest priority queue. Now, if a process is preempted, and it's very important to understand this part, it's preempted. So Q0 and Q1, they have round-robin scheduling algorithms. So the round-robin, it's a preemptive scheduling algorithm. So if the process is preempted, the process will not go back into the same queue, but is gonna move on to the next lower priority queue. Okay. Between these queues, we use non-preemptive scheduling algorithm, and I will go, when we get to the point to see the difference between preemptive and non-preemptive scheduling algorithm between the queues, I will let you know. Okay. So at moment 0, we have process 1 into the ready queue. Process 1 is scheduled. And again, here we have a very special case. There is no process arriving until moment 2. So we don't say, oh, process 1 will execute for a quantum of 1, then it's going to be preempted. Then we schedule it again. No, it doesn't make sense. So process 1 executes until process 2 arrives. Now process 1 is going to be preempted and it moves into the lower queue, into the lower priority queue, which is Q1. So now process 2, which is in Q0, will execute for a quantum of time, for a quantum of 1. And then process 2 will be preempted. And process 2 will go into Q1. Now the scheduler has nothing in Q0, so Q0 it's empty. However, Q1 contains process 1 in front of the queue. So process 1 is scheduled. It's scheduled from Q1. So theoretically, it's allowed to execute 2 units of time. However, process 1 will execute only 1 unit because it's done with its CPU burst. So again, since process 1 comes from Q1, theoretically, it's allowed to execute 2 units. However, process 1 is done with its execution at moment 4. We consider that process 3 is already in Q0 before we take the scheduling decision. So at moment 4, we have process 3 in Q0, process 2 in Q1. So process 3 will be scheduled and is going to move from 4 to 5. After that is preempted and is going to go into the next priority queue, which is Q1. So now at 5, in Q0, we have nothing. In Q1, we already have process 2. And after 2, we have process 3 that was preempted. So the next step we schedule process 2. It comes from Q1, has a quantum of 2. So process 2, it's allowed to execute between 5 and 7. Here is the place where we take in consideration that we don't have that we have a non-preemptive scheduling algorithm compared to a preemptive. Because look what happens. Process 2, it's executing. Process 2 was picked from Q1 and it goes from 5 to 7. However, at 6, we have process 4 coming into a higher priority queue, into Q0. So if we would have preemptive scheduling priority, preemptive priority scheduling algorithm between queues, then process 2 would have been preempted. Okay, let's move on. So at 7, we have process 4 in the highest priority queue. So process 4 is going to be scheduled. It's going to execute for a quantum of 1. So it's going to go from 7 to 8. Process 2 is going to be preempted and it goes into the lowest priority queue. Okay. Okay. So now we got to 8. Yes. At moment 8, process 5 gets into Q0. Process 5 will be scheduled right away. It's in the highest priority queue. Process 4, it's moved down the queues. So now process 4 is going to be in Q1. So we have 3 and 4 in Q1. Process 5 executes for 1 unit of time and then is going to move from, it came from Q0, it's going to move into Q1. In Q1, we already have 3 and 4. So 3 is going to be scheduled and we're going to have left in the Q4 followed by 5. Now, process 3 is scheduled, it's coming from Q1. It's allowed to execute 2 units. It's going to execute from 9 to 11. And then process 3 moves to the lowest priority queue, which is Q2. We already have 2 in there. So we're going to have 2 and 3 in the lowest priority queue. The next will be process 4. Yeah. So in Q1, we are left with 4 and 5. So we're going to have process 4. After process 4 executes 2 units, it's going to move into the lower priority queue. Then next we have 5. 5 executes for only 1 unit. Even if it comes from Q1 and it's allowed to execute 2 units, it's done with the CPU burst, so it's done at 14. So finally at moment 14, we have 3 processes, but they're all in a non-preemptive queue, which is Q2. So we pick the first one, we use first come first serve, process 2. Process 2 will execute until it finishes its execution. So it already executed 3 units, it has 3 left, it goes from 14 to 17. Then we have 3, process 3, it went for 3 units, it has 1 left, and then we have process 4. So again, give it a try. If you don't practice and just look at the video, it's not gonna work that well because you need to practice. And once you get it, it's not hard. The quiz, it's straightforward. And most of the students, they get very good grades in quiz too. Thank you.